Welcome to The Explainer. Today, we are digging into a pretty wild idea. What if the same laws of physics that make a shock absorber work could also be used to predict the crazy swings of the stock market? Yeah, it's a journey that takes us from a mechanic's garage right to the heart of Wall Street.
Okay, so let's jump right in. To really get our heads around this new theory, you first have to understand that we're talking about two totally different universes. The world of engineering, which is all about predictable machines, and the world of finance, home to some of the most unpredictable markets on Earth. And this slide really nails the basic problem, right? On one side, you've got engineering systems. We build them, we understand the physical laws they run on so we can control them and predict what they're going to do. But then you've got financial models. They're abstract, they feel impossible to control, and they have this really annoying habit of working perfectly right up until the moment they just completely fall apart.
So that huge difference between these two worlds, it brings up a really fascinating question. And it's basically the whole point of what we're exploring today. Is it possible to take those rock-solid, reliable rules from engineering and actually use them to make sense of, and maybe even control, the absolute chaos of our economies?
Well, the story behind this idea doesn't start in a bank or a hedge fund. It starts with a mechanical engineer. We're going to follow the journey of this control systems expert who took his super complex models to Wall Street, thinking, he was about to make an absolute fortune.
I mean, look at this guy's background. It's incredible. He mastered the really complex math of random systems at places like MIT and Berkeley. But here's the kicker. When he took all that brainpower and tried to apply it to actually trading stocks, it completely flopped. The market just did not care about his fancy equations.
And that failure, well, it led him to this really raw, honest conclusion. He learned the hard way that you can't fight the market's complexity with more complexity. It made him throw everything out and start looking for a much, much simpler, more fundamental idea about how markets really work.
So, where did his search for a simple strategy take him? Not to some dusty economics textbook. No, it took him all the way back to the basics, like first-year mechanical engineering basics. He landed on this humble little device that's in pretty much every car on the road, a mechanical damper.
A damper is just a shock absorber, the thing that keeps your car from bouncing around like crazy. You can just picture it as a plunger moving through some thick oil. Its whole job is to slow things down. But how it does it, that's the little piece of magic that unlocks this entire theory of economics.
Okay, this is where it gets really, really cool. On the big picture, macro level, all you see is a plunger moving slowly. Kind of boring. But if you could zoom in, way down to the molecular level, something amazing is happening. That single focused push of the plunger is getting broken up and transferred into the random, chaotic jiggling of trillions of little oil molecules. And that random jiggling? That's literally what heat is.
And boom, here is the big analogy. That plunger pushing with all its force, think of that as a huge sell order hitting the market. One big, directed motion. And all those trillions of oil molecules, they're like the countless small traders in the market. They absorb that big shock, and in doing so, that big trade gets spread out, distributed, and diversified across thousands of different hands. That heat is the surplus getting distributed, and the temperature, well, that becomes a way to measure market risk.
Now, this isn't just a clever-sounding metaphor. This analogy actually lets us build a whole new way of measuring financial risk, and it's one that throws out all the abstract guesswork and replaces it with solid, physical principles.
Think about how it's usually done. The old financial models, they're based on abstract ideas like volatility. And that's a number you basically have to guess by looking at what happened in the past. But we all know the past doesn't always tell you what's coming next. This new way is completely different. It uses formulas from physics, actual physics, to figure out risk based on what the market looks like right now.
So what this all boils down to is pretty incredible. It means we could literally build a riskometer for the economy. Seriously. The same way a thermometer measures the random energy of molecules to tell you the temperature, this riskometer could measure the activity and diversification in the market to give us a real-time physical reading of its risk temperature.
So why is this such a big deal? Why does it matter? Because if you can actually measure and model an economy like it's a physical machine, then you can start to do something truly revolutionary. You can start to engineer it.
And get this. This model might even give us a mind-blowing physical explanation for one of the oldest ideas in economics, Adam Smith's invisible hand. From this point of view, the invisible hand isn't some mysterious force. It's just the second law of thermodynamics playing out. the natural tendency for things to spread out and move towards maximum disorder, or in market terms, maximum diversification.
This whole way of thinking leads us to a tool that sounds like it's straight out of science fiction, but it's real. It's the ability to build digital twins of our companies, our industries, or maybe even the entire global economy. These aren't just spreadsheets. They're living, breathing simulations built on engineering principles.
So you can actually see a kind of a roadmap here. Step 1, you build a digital twin of the economy using these engineering rules. Step 2, you plug in this new physics-based way of understanding risk. And then step 3, you apply control theory. I'm talking about the same math we used to land a rover on Mars to actually help steer the economy, smooth out the dangerous bumps, and aim for better outcomes.
It seems that the same deep fundamental laws of energy and motion are at work in both our most advanced machines and our most chaotic markets. And if that's true, it leaves us with one pretty staggering question, doesn't it? What's really stopping us from one day engineering a financial future that's as stable and predictable as the incredible machines we already build today?